explains why it goes up at the end. Why does it go down in the beginning, though? You're saying that as A goes down, the instantaneous selectivity should go up. And you're not wrong, and it does, but it goes down in the beginning. Why? Because the other thing in that equation is a ratio of rate constants. And the rate constants do what as temperature increases? They always increase. But which one increases more quickly than the other? The higher with the higher activation energy, and so if the selectivity is going down, you know that the one with the higher activation energy has to be what? K2 or K1? K2. K2. And so if you look at the plot, this is K2A, is the orange curve. You see it's a it's a log scale here because this is changing quite a bit. They both increase, K2 increases much more quickly than K1. So in other words, to increase the selectivity to your system, you do want low concentration of A, but you also want a low temperature. And those are going to compete as you go down the reactor because the temperature is going up, which hurts your selectivity. And then, of course, as you get to this region, the concentration of A is essentially 0, which means you get a very large value for the instantaneous selectivity. Why isn't it impacting the orange curve, though, is because neither one of them is doing anything. Right? Instantaneous selectivity, it's like 0 divided by 0 at that point. So neither one of them is actually changing the flow rate of B or C in the system, which is why it becomes constant. Let's look at yield. You're going to see some similar things. So this is the instantaneous yield. This is the overall yield. Overall yield is highest at low volumes. Why? Yeah, but you want, in this case, the concentration of A, I believe, cancels out. So if you look at the formula for the yield of B, it's the rate of production of B divided by the rate of consumption of A. No, you're right. There is still a partial dependence in the denominator. But that's actually going to help you. A lower concentration of A is going to increase your yield to B for the same reason that it increases the selectivity to B. And yet, as I go to higher volumes, the concentration of A goes down, and yet my yield goes down. Why? Because you're making more C. It's the same reason. It's the rate constants, right? The yield also has rate constants in it. They're also going to be changing with temperature. And so you're increasing the total rate of consumption of A more rapidly than you're increasing the rate of formation of B. And that's because you're making C. So the yield drops to a value of about 0.3, and then it starts to increase and go back to 1, but again, that's the instantaneous yield. It goes back to 1. And it goes to 1 because, for the same reason that the selectivity, the instantaneous selectivity goes to infinity, that the concentration of A is very low at that point. And then what happens to the overall yield, which is, again, the amount of B made divided by the amount of A consumed, is it tracks the instantaneous one, but then it flattens out in this region again because you've stopped consuming A. So if you're not consuming any more A, you can't change either the amount of B formed or the overall yield of B. Any questions about how to set this up in Excel or otherwise and interpret when you have multiple reactions and heat effects for those reactions?
Would you be able to post this online? I know that would help us with the homework maybe more if you wanted to, but these are really helpful.
I will post these after the homework is turned in.
I have a question before you close it, though. About how much of a difference do you think it'll make if, for instance, because what I always do is I
guys, don't leave while somebody's asking a question, please. It's noisy, and he might be asking something you don't know either.
If you drag it down once, when you put in all your initial values, and then I put all the cell references, because to avoid circular references, I just put them all to the point above it. essentially.
Yeah, that's fine. It's a very slight error, but it's
And
fine.
you don't think it makes that big of a
No,
difference?
and in fact, I mean, I tested that. Somebody asked me that, and they were sitting in my office. I switched it, and it didn't make any difference.
Okay. I think that usually.
But I mean, one thing to notice of when you drag, I mean, everybody might not know it, but you can just double click this thing, and it'll
Yeah.
drag down. And you don't want to drag like this, because then it's going to repeat the pattern. You only want it to take this formula, because sometimes those
Right.
formulas are different.
That's what. Yeah, the top one is always different. But that's why
Not
I set it up
always.
with the initial.
Well, they're always in your case,
Yeah.
but not always.
So I
The
set it
rate
with the
constant
initial
ones are always the same.
Yeah.
All right. See you guys in a couple of weeks. Enjoy the test.